In this video, we're going to be discovering what the third logarithmic law is. It's the third major logarithmic law, and it's a lot simpler than the first two. And let's try and remind ourselves what the first two were. The first one was basically the addition of logarithms. We dealt with the addition of logarithms. And the second one, we dealt with the subtraction of logarithms. Now here we're going to do something different, out of the ordinary, and I think it deserves a different color. No, let's deal with something here. If I said we had log to the base a of b raised to the power n, raised to the power n, you're probably going to ask, well, how am I going to express this? As always, I'm going to show you how to express it, but if you do want the proof for it, I have a video, and please have a look at it if it helps you understand the concept better. It did for me. So how I'd rewrite this is I'd just take the n down here, and I'd write n multiplied by log to the base a of b. Oops, this is more orange than this, but anyway, you get the point. All I did was I just took this n. I just took the n and placed it right down there. And this n log to the base a of b can basically be written like this. I don't need to show the multiplication sign. That's all it means. And let me show you a couple of examples. It's a pretty straightforward one. Let me show you a couple of examples. Let's say we had log to the base 5 of 7 cubed, and let me write this 3 in a different color so we can see what happens to it clearly. Alright, 7 cubed. Well, I'm not getting my colors right, but I think you're getting the point. Well, this would be exactly the same. This would be exactly the same as writing log. Well, oops. Let me write this properly. This will be exactly the same. I'm sorry about this one. 3 times the logarithm to my base 5 of 7. I see this color thing's not working, so, but I think you're getting the point. Well, this is basically 3 log 5 base 5 of 7. That's all I've written in this equation. Let's try another one so we can get the hang of what we're doing. If I gave you log to the base 3 of how about 8 to the power of 5. Why not? This would be, all I have to do is take this 5 down here, and I just rewrite it. 5 times the log to the base 3 of 8. Let's do just one extra example so we can say, yep, we've done it and we get it. How about that? And let's say I had log to the base, let's say 9 of 10 squared. 10 squared. That, let me just close this. It's pissing me. It irritates me. Of 10 squared. That would be, take the 2 down here. That would be 2 log to the base 9 of 10, and that's all it means. That's all we're doing. Nothing too complex about it. It may not seem too intuitive at first, but if you check out the proof, you will see exactly how it comes about and why it should make some sense. Now we're going to do extra examples, but in this case we're going to deal with something a little more different. How about if I said, well, before we go any further, let me just say I had 3 log to the base 4 of 5. Well, how would I write this? What would I do to the 3? Well, we know the 3 can be put over here, or we can just rewrite it as log to the base 4 of 5 raised to the power 3. Because remember, if I gave you this initially, if I gave you this value here initially, all you do is take the 3 down here, right? Down there as a coefficient or as a multiple product of value you should have, something you should multiply by. Well, that's exactly what it means. I mean, that'll be bringing me down to this right here. It'll just bring 3 log base 4 or 5. And I can just rewind the process, sort of, reverse the process, and it'll get me back to the same value. So let's do one more just so we can say we get the point. If I gave you 2 log to the base, let's say 5 of 7, that would be exactly the same as saying log to the base 5 of 7. We take the 2 back to its spot to the power 2. Which, if you don't like to express them and you want to break them down, you can go ahead and say log to the base 5 of 49. Why not? Same thing, depends on what your preferences are. Now let's try and make a simple little equation here, and let's see what we can do with it. If I gave you 2 log to the base 7 of 5, right? Plus log to the base 7 of 3. And I ask you, what would I get? Well, the first thing I encourage you to do is first simplify this with the new rule we've just learned before you go any further. Simplify this, and let's see what it simplifies to. This would be log to the base 7 of 5 squared, which is the same as log to the base 7 of 25. So what this equation then reduces to would be log to the base 7 of 25. Instead of writing this heap of a mess, we can just break it down to something simple like this, plus log to the base 7 of 3. Now we have 2 values, both to the same base, both with logarithms to the same base. What do we know about adding logarithms? Just multiply what we have in them. Let me just bring this down a little bit. Let me drag this down, and let's bring it down over here. And it says log to the base 7 of 25 plus log to the base 7 of 3 is simply equals to log to the base 7 of 25 times 3, which, by the way, is log to the base 7 of 75. Right? I hope this is it's not too bad, right? So let's try one more example so we can say we're done before we call it a day, right? If I gave you, let's say, 3 log to the base 7, let's change this with base, let's make it log base 9 of 4 plus, and let's make this one of these two, and let's write it as 2 log base 9 of 5. Why not? Why not? What would this value equate to? Well, let's simplify each of them. Let's simplify each of the values first. Well, this right here I can rewrite as log to the base 9 of 4 raised to the 3, plus log, I'm going to rewrite this down here as with the new rule we just learned, log to the base 9 of 5 squared. That would be equals to log to the base 9 of 64 plus log to the base 9 of 25. And what we know this boils down to, this would be log to the base 9 of 64 times 25. That's what it boils down to because it's the addition of logarithms. So imagine I had a calculator with me. Well, this would be, imagine I punched it in because that's what I've done. This would be log to the base 9 of 1600, which is an unusually big number to find with logarithms, but I was just arbitrarily picking up the question, and that's what it boils down to. See you in the next video.